So let's continue. Now we have a synergetic cube octahedron. It has 2.5 these tetra volumes, contains 60 A and B modules. It's impossible to model. It doesn't exist in synergetics. This cube octahedron doesn't exist. And it is impossible to model with isotropic vector matrix sphere, as you see. This crucial structure is missing from the order, labeled half frequency, thus unimportant to synergetics. Now we have a one frequency Z cube octahedron, which is this one, equals 20 tet volumes. Unit radius sphere, there is 12 around one of these spheres. You can pack this with this one, 12 around one. I want to show the cross section in here, which is very important. This is the cross section, and we see that what you guys label a unit radius sphere is actually a unit diameter sphere, because this sphere can enclose this cube octahedron exactly. Then we have a one frequency synergetics cube, that's this one. It contains 72 A and B modules. Now 24 mites, which are this one, we have same mites, me and synergetics. So there is 24 of these fits into that cube. Mite is a 1/3 of the small cube. It's impossible to model in synergetics, but nevertheless 72 modular cube must be two frequency. When mite is divided into 3, like this is a synergetics mite, and it's divided into 3, and it equals nothing. If I divide this to 2, I can make a square base, irregular half octahedron, and 3 of these make a cube. So that's clever. This is nothing. Now we have a two frequency Z cube, that's this one. It's same like the synergetics cube, of course. Exactly, same thing. And this cube contains also 24 mites, 124, this is a 124 diamond, and mite is a 1/3 of a small cube, possible to model, thus 24 modular cube equals 2 frequency. Mite divided into 2 equals 1/3 of the cube, and that's clever. Now we have a one frequency synergetics octahedron, that's this one in here, equals 96 modules, equals volume 4, 4 of these. 12 A and B modules would be 1/8 of this octahedron, it would look like that. It's impossible to model or spare pack in synergetics. Nevertheless, this octahedron is two frequency, this is one frequency. Two frequency Zubek octahedron, it's here, which is same, of course, they are exactly same, equals 32 regular tet volume. 1/8 octahedron equals 4 tet volume, possible to model that octahedron is two frequency. Now the next one is a rhombic trichontahedron. What frequency is the synergetics volume 5 trichontahedron? I have a question mark, I don't know, but it equals 120 modules. It has volume 5 of this tetrahedron. This trichonta is artificially placed between the octahedron and the rhombic dodecahedron. So it should be here, placed in this gap in here. That's what that should be. A rhombic trichontahedron long diagonal, this is the 7.5 synergetics tetra volumes, and this long diagonal is the edge of this cube or a synergetics cube. Even though this fact is denied by Kirby, apparently synergetics has it different, as he explains. In either case, the long diagonal is indeed the cube edge, even in synergetics, well, at least sometime. These relations do not change. If there would be a two frequency, if there would be two rhombic tricontahedrons in the same hierarchy, its volume would be also 7.5 small regular tetrahedral volumes. That would be these ones. And this tricontahedra would be placed after the 8-block octahedron or 12-block octahedron, so it would be somewhere in here. And its long diagonal would be the edge of this small cube. But since synergetics does not have these solids, volume 5 rhombic triconta is nothing more than a poor and an induced mathematical example. In short, the volume 5 triconta equals 2 cube octahedrons volume. In other words, this rhombic triconta does not exist. Its long diagonal does not equal any cube's edge. This is an abstract, irrelevant, non-existent solid.